For decades, scientists have been trying to develop aircraft that can travel at the speed of light so that some of the most fundamental questions of human existence can be answered. How did we come to be, and what lies out there in the vast open? With this new NASA creation, it just might be possible to finally get those questions answered. In this video, we will talk about the latest discovery and uncover what is in store for the future of NASA, so let's get right into it. First up, what exactly is light speed? As its name suggests, light speed is the speed at which light travels through a vacuum. It is approximately 671 million miles per hour. You cannot imagine how fast that actually is. It is the fastest speed at which anything can travel and is a fundamental constant of nature. According to the laws of physics, only electromagnetic waves such as light, radio waves, and gamma rays can travel at the speed of light in a vacuum. These waves are known as massless particles, which means they have no rest mass and can reach the speed of light. These waves can travel through a vacuum such as space without any resistance or interference. Particles with rest mass, such as protons, electrons, and atoms, can never reach the speed of light. Even though they can be accelerated to very high speeds, they will always be traveling slower than the speed of light in a vacuum. Because of its incredibly high speed, light is often used as a reference point for other velocities in physics. For example, the speed of an object traveling through space is often measured in terms of how fast it is moving relative to the speed of light. The speed of light is the maximum speed at which energy, matter, and information can travel in the universe, and it is a fundamental constant of nature. According to the theory of relativity, as an object approaches the speed of light, its mass increases, and an infinite amount of energy is required to accelerate it to the speed of light. For this very reason, it's considered impossible for any object with mass to reach the speed of light. Even the fastest man-made spacecraft, the Parker Solar Probe, which was launched in 2018, is only able to reach speeds of up to 430,000 miles per hour, which is a tiny fraction of the speed of light. In the past, NASA has focused its efforts on developing spacecraft that can travel at high speeds within our solar system, such as the Parker Solar Probe and the New Horizons spacecraft, which have reached high speeds by taking advantage of gravity assistance from planets to increase their speed. NASA's research has also been focused on developing propulsion technologies that can allow spacecraft to travel faster and farther than ever before, such as ion thrusters, solar sails, and antimatter propulsion systems. However, these technologies have been far from reaching the speed of light, and even if they were to reach it, it would have been impossible to carry humans or any other living organism on board. Additionally, NASA has conducted research on various theories of physics and cosmology, such as the possibility of wormholes or other shortcuts through spacetime that might one day allow for faster-than-light travel. However, these ideas have been purely theoretical and have not yet been proven to be possible. In recent years, NASA has been investigating specific ways to design spacecraft that could potentially surpass the speed of light by exploring new propulsion systems. This research is pushing the limits of physics and attempting to achieve what was once thought to be impossible. It has been exploring an alternative way to potentially overcome the speed of light barrier by warping the fabric of spacetime itself instead of trying to increase the kinetic energy of an object. As proposed by Dr. Harold "Sonny" White in 2012 during his presentation to NASA for its research into this field, NASA developed the Advanced Propulsion Physics Laboratory, also known as the Eagle Works Laboratories, which is a research facility within NASA's Johnson Space Center. The laboratory's main focus is on developing advanced propulsion technologies for space travel, including those that could potentially allow for faster-than-light travel. The lab conducts research on a variety of topics, including the study of the behavior of matter and energy in extreme environments, the testing of advanced propulsion systems, and the development of new technologies for space exploration. The lab also conducts research on theories of physics, such as the possibility of wormholes or other shortcuts through spacetime that could one day enable faster-than-light travel. It is led by Dr. Harold White and his team, who are investigating the feasibility of these ideas. In the past, the research conducted by the Advanced Propulsion Physics Laboratory may not have had immediate practical applications, but it was still significant because it addressed questions that other scientists had not yet considered. The laboratory's goal was to develop propulsion technologies that would enable human exploration of the solar system in the next 50 years. The initial prediction for the amount of energy required for faster-than-light travel was incredibly high, estimated to be 1 billion times the total energy in the universe. However, over time, scientists have been able to reduce this estimate, first to a few times the energy of the Sun, and now to roughly the mass of Jupiter. Dr. White's proposal was to design a warp that could potentially reach the star Alpha Centauri within a few weeks at a cost similar to that of a car. He presented this idea to NASA and was granted a space at the Johnson Space Center to establish the Eagle Works laboratories. Since then, the laboratory has been focused on 3 main projects: validating a time warp field, generating thrust by manipulating quantum particles in a vacuum, and testing several resonant cavity thrusters. Though there have been some promising results from these tests, more research is needed in the future. The laboratory quickly built an instrument called the White-Jude Warp Field Interferometer to measure the very small changes in spacetime that will be required for this technology. Positive results were being achieved, but it was unclear how this technology could be scaled up to propel a spacecraft. Dr. White even created a concept art of a ship that could potentially utilize this technology, called the IXS Enterprise, featuring wings that would create the warp bubble. While Dr. White paved the way for future scientists to make further discoveries, which could allow NASA to develop an aircraft that would travel at the speed of light, NASA engineer David Burns was next in line to further this research. He proposed a new concept for an engine that can travel at the speed of light without the use of any propellant, based on an M-drive. The M-drive, or electromagnetic drive, is a proposed propulsion system that would generate thrust without the need for any external fuel source. The idea was first proposed by Roger Shawyer in 2001, and it is based on the concept of using microwaves to create thrust. The M-drive has been considered a violation of the law of conservation of momentum and other physical principles, and it is often referred to as the impossible drive by the media. However, recent scientific studies have shown that the M-drive can create thrust, but the reason for this is still not understood. Based on this concept, Burns has come up with his helical engine, using a combination of high-tech particle accelerators such as those found in the Large Hadron Collider and taking advantage of the way mass changes while traveling at the speed of light. Burns's helical engine, also known as the engine of light, could potentially reach speeds of 297 million meters per second. In a paper uploaded on NASA's website, Burns used a metaphor of a weight inside a box threaded on a line with springs at either end to explain his concept. The potential for the helical engine to revolutionize space travel was significant. It could potentially reduce travel time between planets and even galaxies to a fraction of what it is currently. Additionally, it could also reduce the need for large amounts of fuel and improve the efficiency of space travel. The development of the helical engine is being closely watched by scientists and engineers around the world, and it will be exciting to see how it evolves in the future. The helical engine utilizes particle accelerators similar to those found in the Large Hadron Collider. Through the use of electromagnets, particles are accelerated to high speeds and recycled back through the engine to be fired again. Newton's laws of motion state that every action must be met with an equal and opposite reaction. This principle is demonstrated in an experiment where a spring is placed inside a box, and when the spring is compressed, the box moves in the opposite direction. When the spring reaches the end of the box, it bounces back, causing the recoil direction of the box to change and creating a loop. However, if the mass of the weight inside the box were to increase in one direction, it would result in a larger push in that direction and greater thrust. Special relativity theory states that as a particle approaches the speed of light, its mass increases. If ions were used in place of the weight and the box was replaced with a loop, it is theoretically possible to make the ions move faster at one end of the loop and slower at the other, resulting in thrust. But in practice, the engine would have to be large, measuring 200 meters long and 12 meters in diameter, and require 165 megawatts of power to generate 1 newton of thrust. It would only be able to reach meaningful speeds in the frictionless environment of space. However, not every researcher is in support of this propellantless engine. The electromagnetic drive, or the RF resonant cavity thruster, is a propulsion system that generates thrust by bouncing microwaves around inside a closed chamber. Some researchers have claimed that the M-drive produces thrust without the need for any propellant, which would violate the laws of physics as we currently understand them. Martin Tajmar, a researcher at the Dresden University of Technology in Germany, has performed tests on the M drive and believes that it is likely to suffer from the same problem as other inertial propulsion systems, which is that they do not work in a friction-free environment. Tajmar's research suggests that the thrust generated by the M drive is due to experimental errors rather than an actual physical effect. However, his team is still conducting further tests to try to understand what is happening. On the other hand, some researchers believe that the helical engine could be a significant breakthrough in propulsion technology. If the engine works as Burns has proposed, it could potentially revolutionize space travel by providing a way to reach incredible speeds without the need for large amounts of fuel. This would make space travel more affordable and efficient, and it could open up new possibilities for human exploration of the solar system and beyond. In conclusion, NASA is pushing the limits of space exploration and propulsion technology with groundbreaking research that could one day lead to faster-than-light travel. While these concepts are still in the early stages of development, they offer exciting possibilities for the future of space exploration. We look forward to what the next breakthroughs will be in this rapidly evolving field.